All right, so now we start recording the lecture. Please, if you have any questions, just write me in the chat room, and then I will ask you, and then you can answer the questions. If you remember, on Monday we did manage to solve this question. By the way, at the end of this session, I will publish this PowerPoint slides for you guys, which shows all the working out for different questions. And the answers for this question, which we managed to finish it on Monday, is part of it. And then we managed to finish another question, example 2, about friction, and the solutions for that question. If two possibilities, could be the block moving downwards or could be the block moving upwards, but we want to just make sure what's the range of P for that value. And some of you were confused about the solutions for that. Therefore, I prepared the new questions about friction, another one. So this is example 3. Let's try to read it together. And this is something, some hints on for you guys, for you to help you to work in exams or in the final exam paper, which is next week on Tuesday. First of all, my advice for you guys when you're trying to attempt any exam, I would like you first to attempt the questions you know the best. Before that, you must read all the questions, make sure everything you know about it, and then you decide, yes, I'll start with this one because I know more information about it. So for example, we got this question. An object of mass of 250 kgs is pulled along a horizontal surface at a constant speed by a force of 650 newtons at an angle of 22.6 degrees to the horizontal as shown in this figure. Calculate the coefficients of friction between the object and the surface. So the mu value between the object and the surface of this. Now, when we get this type of questions, I really prefer you guys to highlight the questions or the words. So try to highlight this information, like what's 250 and what's the horizontal, what's the angle, what's the 650 newtons. When you highlight this information, it will be very easy for you to start solving this question. So step 1, I will highlight the information. When you highlight the information, you find like the most valuable is the mass of that block or object, and then it's on the horizontal surface. Constant speed is a good information. There is a 650 newtons with a 22.6 degrees the angle. And as well, he wants us to calculate the coefficients of friction between the object and the surface. So technically, I'm still in the process of reading the question. I just want to know what's is next for it. So rule number 1, since we make you first day on this course, we start with free body diagram. So how can I show, what are the requirements to show in my free body diagram? I need to show all the external forces on it as well. Anything could impact on it. So for example, when I start drawing the free body diagram, you will get something similar to this diagram. So what's this diagram will tell you? First of all, you have the mass times gravity acceleration 9.81, which represent for you the weight of the object. Since the force is 650 newtons moving that way, therefore I need to have an arrow to say the direction of motion. So let's say this is the direction of motion, and we know how to represent that. Direction of motion, DOM. This direction of motion would tells me that the friction force is always opposite to it. Therefore, to draw the free body diagram, I need to allocate this force, which is an external force 650 newtons with the angle 22.6, and I will allocate the weight of the object times the gravity acceleration. Opposite to that, what do you have? You will have always the normal force or reaction normal force. And then as an extra, you can show the components analysis for the 650. But it's very important here, what we need to do is to show in the question the coordinates or the x's you're trying to assume to solve this problem. So I need I need to specify in my question, this is my x-axis, and this is my y-axis. So I'll type here x, and I'll type here y. Sadly, many of you will say why we are doing this level of question. Sadly, many of you will lose marks. As you've seen in the test, you will lose marks because you're missing to put the coordinates of your x's, or you're not really clear. So this is the free body diagram. Questions, some people, they can put the components of the force analysis, like for example, 650 cosine 22.6 or 650 sine 22.6. After we found or finished the free body diagram in this question, we move to the next step, is to calculate the forces in the x direction and the forces in the y direction, but I need to find Py and Px. Therefore, that will be in a very simple equation. So what do you have? 650, this force, which is given to us, times cosine 22.6 will give you 600 newtons. So this is the components of the x-axis. The same thing, the force in the y direction, 650 sine 22.6, and that's what represent for me the force in the y direction. After we allocated that, now the next step, you need to find the information given to you. Remember, the question wants us to calculate the coefficients of friction, which is the mu value. That's the purpose of the question. So we need always to put this in our mind. To calculate that, you have two different equations, such as we learned. To find summation of forces in the vertical direction, and as well forces in the horizontal direction. But we're taking into account the friction, because we need to put all the values together. So let's work on this step by step. So if we try to write the equation for summation of forces in the vertical direction, or as we say, it's the y, what do you have? First one, you can see all the forces going upwards. So I can take this arrow and put it next to this to represent for me, this is my vertical directions. Please, it's very, very important to add these components to your drawing, because you are telling us, or telling the person who's reading behind you or after you, that, hey, this is my vertical. I'm going with every force going in that direction. And going upwards represent is positive. So if you have a force going downwards, represent is negative. So that's very, very important. So what do you have? Normal force is a positive value, minus the weight, which is negative value, because going downwards, which is normal, going towards the gravity acceleration. Plus, what do you have? You have the components for the Py, the 650 times sine 22.6, which is 250. Rearranging this equation and substituting the values. So what you have, the normal force equals to what? 250, which is the mass, times 9.81 to change or convert the mass to weight as a force, and minus 250, which is the components of the vertical force for the 650. Subtracting these values, because of course they are going in different directions, you will get an answer 2,202.5 newtons. I hope the answer is correct. If something is wrong, please, guys, correct me. Now, when we try to do that, please make sure, this is very, very important for you guys, is to really state the components of the direction, positive, negative, because you need to tell us how you are assuming, is this positive or negative. And since you don't really need to follow what I'm doing here, because you will have a paper and you can answer everything easily, you just put next to that arrow that everything is going upwards, is in that direction, is positive. This is very easy. Or you could also try to use the same principles as we show here. This is my positive x direction. This is my positive y direction. And you solve with respect to that. And you change from vertical words to be x, which I will do it now. And that means you're solving it with respect to that. It's very important to bring these references with us because it's kind of telling us what we're trying to achieve in this question. I'll put it here so I always remember where is my positive x, where is my positive y. Now, what I want you to do, guys, is to do the same thing to find, sorry, there was one issue. This should be y. It's vertical, sorry. So this should be y, not x. Now, I want you what to do, guys, is to find the components of the forces in the horizontal. I will give you time. I want you to finish this question, and based on it, you can determine the value of the coefficients of friction and write me on the chat the number for that question or the final answer. So Sagar is here, Min is here. Good to see all of you guys. And Iran is here. Darren. Okay, so I start getting answers. Good, that's good. So who did join us? Ellen joined us, Ronil, and Caleb, Matthew, Man, Sagar, Sean. Good. Caleb, the friction is 600.1 newtons. I think I might leave early because my battery. Okay. Need to have your charger with you, but anyway, this will be recorded. All right, let's try to investigate the answer now for this part. Should not really take you a long time since you guys are doing really kind of revision for this paper. So again, when I solved this question, I did it in terms of vertical and horizontal. Horizontal represents the x direction. So summation of forces in the horizontal. What do you have? You have the components px, which is the 650 cosine 22.6, minus the friction force. Now, do you remember what the friction force equals to? Let's write it on the side. Friction force equals to what? By the way, equation should be given to you in the exams. Equals what? Do you remember, guys? The coefficients times what? Times Rn, the normal force. So instead of that, I could easily substitute the values. Px minus friction force is equal to 0 because these are the only two components on the horizontal direction, Px and Ff. Therefore, I could easily substitute this equation. Instead of writing it in mu Rn, I could put the value of Rn times the mu, and therefore rearranging the equation, you will get mu 0.272. Now the question, what's the dimensions for the coefficients of friction? Any idea? Hello, Thais, how are you? So what is the dimension for this? Is it okay to submit the answer like that, or I'm missing the dimensions? So I'm waiting for answers. What's the dimension for the mu? Matthew, you're correct. I'm waiting for the others to answer. Caleb, yes, you're correct. So we call it, there's a term we call it. Parpinder is not constant, it's something else. Michael Robinson, yes, correct. Dimensions, for example, the dimensions for the force is newtons. Dimensions for pressure, it's Pascal. Dimensions for distance is meters. So what's the dimension for the coefficients of friction? Yes, Michael Chandra, correct now? So the answer for that is a coefficient. So this coefficient doesn't have any dimensions, and that's why it's, if you look carefully to this equation, if you rearrange this equation, mu is equal to what? Mu equals the friction force divided by the normal force. So that's why this coefficient is dimensionless, because technically you're dividing newtons divided by newtons or kilonewtons divided by kilonewtons, and therefore they will have no dimensions. So it's a very easy question. I will say yes. Why you started with easy question? You know me, guys. I always start with very simple questions to encourage you to start with the topic, and then we build our information and we move to something maybe more advanced. So I will give you time if you have any questions before we move to the second or the fourth example, because the fourth example will take you slightly to different topics as well. Checking the chat room. So Perpinder, we call it dimensionless, so that's how we give it. Hey, me and Ninad are online. Well done. Wesley, you and Ninad, well done. So you need to find vertical force and horizontal to find the coefficients. Is that the only way to figure it out? Yes, it's the only way to figure it out. All right. So this is example number 3. It's about friction, very easy, very basic. Now, you know what I like to do, guys? I would like you always to think about different ways of the question itself. So let us think about how can we play around this question. But I will not solve it for you guys because I want you guys to think about it. So if in case this force was placed here, what do you think will happen to the solution? I'll give you time to think. If, and let's say this is the weight of that, I'll just make sure it doesn't resume it. Oh no, that's too much zooming. So if that's for 650 newtons was placed in that position, can you please answer in the chat and tells me what's the different things will happen? Yes, I saw you. You're in. Different reaction force? No, we don't have reaction force in this question. Matthew, you're correct. Michael Chandra, are you asking me or are you answering? You need to answer or then. So to show you, that was how it looks like at the beginning of the question. Now I change it to that location. So to answer you guys is the same solution, because again, we will do the same analysis, forces in the X direction or horizontal and forces in the Y direction. So please don't get confused if you find the force is acting on different points. Always be confident, try to find the components of that force in the X and Y direction. So very simply, bring this one and bring this one, Control C, and then you go to the main question, the one I changed things in it, and then you shift them here, and that's what will be. So exactly the same thing. You still have the same angle, the same value, therefore the answer will be the same and nothing will change in that question. It's just a trick to confuse you that the force has changed its location, because we're not taking into consideration the distance between the centroid till the end of that object. All right, so this is just a tricky way to just see how you guys think about this type of changing things during the question. All right, now if we go and check another example, if you don't have any questions, if you have a question, please ask now for this question before we move to the next example. All right, no questions, so I will move to example 4. By the way, I will publish this PowerPoint slides into Moodle, such as I did for the fluid topics. All right, example 4. I'll give you time to read example 4. At least I want you to try it, guys, before we try this process. And I want you to try this example and then we discuss it together. Yes, this video is recorded and will be uploaded into YouTube. So how many students we have? 19 students online now at the moment. That's a good number. If you find the answer for part A, please start posting into the chat room. So what you do, exactly how we, what you do, you actually do what we done. You need to work step by step, highlight the information when you read the question, and try from this question to move step by step, answering part A and part B, and then part C. By the way, we have today questions about centroid, about conservation of energy, about beam. One is support at both ends, the other one is cantilever. And as well, velocity. So we have a good collections of examples and questions today. Right, anyone managed to find the answer for part A? Let's read it together. So in a pulley system, the pull on the tight side of a belt is 1,880 newtons. And that's on the slack side is 840 newtons. The driven pulley, or the driving pulley, has a diameter of 250 millimeters, and it's rotating at 1,200 RPM, revolution per minute. The driven pulley has a diameter of 180 millimeters. Calculate. First part wants you to determine the torque in Newton meters. So the question, how can we find, or what's the equation we need to use to get that torque in newtons per meters? So if you look to the questions, what do you have? You have a belt is 1,880 newtons. And the other one is 840 newtons. This will represent kind of forces for you. Now, torque is equal to what? That's why I want you to guys think about it. And then that torque will be converted to where to give you in terms of newtons meters. Okay, I start getting the first answer, hopefully. Hello, Dan, how are you? Good to see you. I don't mind, guys, if you join all of you in one screen and you sit in a corner and you can hear me. I mean, I don't mind that, because remember, it's a group discussion today. I want you to work on it. All right. So if we try to solve this example step by step, I really want you to work it out. So just tell me, how can we work on this one? Try to solve here for you step by step and show you how we work on this example. So solutions, A, part A, the torque. First of all, what do we have? We have the net force given to us. The net force is equal to what? The tensions coming from both belts. So we have tension 1 minus tension 2 because they are opposite directions. So I would just write the proper equations for that. So T1 minus T2. It depends which one you define, T1 and T2. Equals. So I put the numbers. The big number, which is 1,880 minus 840. This will give you 1,040 newtons. So this is kind of representing for you the net force for it. Now, what's missing here in this part, remember, this is a pulley system. So it has a diameter. And what's the diameter for the driven pulley? As you see here, I will put a line underneath this, and I just highlight this word, which has a diameter of 250 millimeters. But I want to convert this torque to be at the center for it. Therefore, if I want to calculate the torque, so the torque equals to what? So the force we found times the distance. Since the distance is the pulley's diameter to the center of it, so that will be, for example, the force we found, 1,040 newtons, multiplied by, here's where you need to find it out very, very carefully. So what we have, first of all, the diameter is given to us in millimeters. So I need to change that to meters. So 250, I'm using my calculator, divided by 1,000, that will give me 0.25. And since I want it at the centers of that pulley, so that will be divided by 2 to treat it as a radius. So what we done is kind of we did net force times radius. So that's technically what we done in this equation. This will give you an answer of 130 newtons meters. This is the answer for the first part. Let's see the one person type, Sagar. Can we get a free bidiagram for the to get a better understanding and view? That's a very good question, Sagar. Some of the questions you will not really get a free body diagram for them, and this is one of the tricky things for it. So really, it's something you need to to understand it. So what's she saying? You just try to sketch it based on your understanding. You have a pulley system. The pull on the tight side of a belt is 1,880 newtons, and that on the slack side is 840 newtons. The driven pulley has a diameter of 250 millimeters and is rotating in that direction. Driven pulley has a diameter of 180 millimeters. So it's kind of, you have two different pulleys which you need to find between them. So one is the driving pulley, the other one is the driven. So kind of similar to the question you guys, I think you got in the test too, but then you will have different belts in this question. So what you have, you just draw the network between them, and then you find it for it. So if whatever is the torques between them, there will be, or the torques is generated for them. Now there is a good question coming. It's a torque a moment? No, the torque is not a moment. Even they have the same units. Torques always involve a rotational motion. Moment is a try or attempt to rotate an object around different points. So that's something, they have the same units, but they are not the same. Now, the second part of this question wants you to calculate the power. So part B, power is equal watts. If you have the formula sheets open with you, it will help you a lot. But if you don't have the formula sheets, I'll write the equation here for you so you can just see it looks like 2 pi times what do we have? It's the speed, which we represent by N, which is 1,200 RPM, revolution per minute, times what? Times the torque we're trying to find, divided by 60. Why 60? Because we are converting from revolution per minute to revolution per second. So if I substitute the values here, so what do we have? For example, it's 2 pi, just write again, 2 pi, 2 pi times, here will be, oh no, not division. Control S, this one, just need to, so that's 1,200, which representing the rotating for the driving pulley, and then multiplied by what? Multiplied by the torque we found, 130, and then divided by 60 because we are converting the RPM to revolution per second. This will give you the power for that one, because we're trying to find the power transmitted. The power always transmitted from the driving pulley to the driven one. And that will give you, if you try your calculator, 16.3 kilowatts. Just I'll change this, and then you get that. I'll try to read now comments. Caleb, would we use the same Fnet to calculate torque on the other pulley? Yes, if that will help us to find something different. But the question is, do you think they should have different torques or the same torque? That's where you really need to know, because the information give, the pull on the tight side of the belt is that value, and the slack side is that value, and they have different diameters. So do we rely on the driving pulley or the driven one? Now, since we find the power for that, the third part of this question, the speed in radians per second of the driven pulley. So now we're trying to find the speed, which is kind of omega, r radians per second. So how can we determine omega for that? So if we just introduce you or remind you about the equation, omega is equals to what? So first of all, how can we find that? It should be a ratio or not. That's what I want you to do. I will give you time to think about what's the equation, and then you can reply by chat what should be the equation to calculate the speed in radians per second of the driven pulley. So can you please, I'll give you time at least to think about, and then I'll share with you the solutions together. Yes, Michael. I will try to find you a picture very soon. Go and find the picture. Okay, I find you where you can find this information which we are discussing now in your lecture notes, which is very something I want you to read. So anyone managed to determine this part? Necessary? All right, don't worry. I will show you this very soon now. So if you guys are a bit confused about what exactly we're doing and how can we determine that, I really guys recommend for you to go to the topic which we discussed earlier, linear angular motion. So this is the lecture notes for linear and angular motion. I'll start from the topic first. So linear angular motion. Yeah, this lecture notes will tell you about many things about linear motion spheres and this topic related to that. But the topic or related to this example, it's actually at the end of this. So here, motion of geared and belt drives. This is exactly the topic of it. So when one applies the principles of linear and angular motion to the situation where two gears of different sizes are meshed together, or the situation where two pulleys of different sizes are connected by a belt, a simple rule applies. So here is the figure, for example, for this one. In the case of pulleys of different sizes, you get B and A, which means they have different diameters. Your sound volume is low. Okay, now is it better? Sorry, I put the mics a bit higher. Is it better now, the volume? Good. So in the case of pulleys of different sizes connected by a belt, as shown in the figure below, the situation is similar. The ratio depends on respective diameters of the pulleys. If pulleys A has a diameter of 150 millimeters and pulley B has a diameter of 450, then the smaller pulley will rotate 3 times as fast as the bigger one. And here we'll show you this example, which it describes for you, which is, it's exactly what we were trying to talk about. Like, it's a very good example for it. Now, I'm quite sure you have gone through this. I'll not go through that example because it's just basic calculations for it. But the most important of this part, why I brought you this, because there is a relationship between both pulleys in their radius and what? Their speed, because that's where it's the equation I'm trying to find. So what does mean that? It's mean that's, if you remember in that question, there is, and this one is saying one pulley has 60 RPM and the other one 240 RPM during 360 revolutions is accelerated. It's like moved from that value to another value. And the diameters here, for some reason, given in centimeters. So you have the bigger pulley is 30 centimeters. The smaller one is 20 centimeters. And this would generate for you different speeds, and makes sense for guys. When you look into the pulleys, you find the one with the biggest diameter will rotate slower than the one with the smaller diameter. The smaller diameter is really faster because the torque for it. So that's to answer your question, buddy. The torque is actually is very important to measure for us And what we're trying to determine is the power, because based on the torque you're generating, it means the tensions on these belts transmitted to the center of the driving pulley will be transmitted as power, which we need to run the pulley, which is the driving pulley. Now, to determine the other part of this question is to determine the speed in radians per second of the driven pulley, which in this scenario is the smaller pulley, which similar to that one. So if we're trying to determine for the smaller pulley, for that one, the speed, what do you reckon is the equation will be for that? So I'll go back to the slides to share with you guys the slides. All right. So now, since we're talking about that, it's kind of you trying to find the relationship between them. And very easy relationship. It's not really that complicated. How starts this relationship? So first of all, it's a ratio between what? The biggest diameter divided by the smaller diameter. Even if you have radius, because remember they will cancel each off. Like if you say the units will cancel itself. So if you have 0.25 divided by 1.8, you get the same answer if it's 250 divided by 180. If it was 250 divided by 2 and all of that divided by 180 divided by 2, so the 2 will be disappear from both sides. So first thing is the relationship between both diameters for the bigger pulley and the smaller one times. Now the answer he wants in terms of angular velocity, therefore we need to introduce the 2 pi, because that's what give it as an answer in radians. Now, what's missing in that part, it's we need to relate to the other value which we have. So what's the other value? Because there's a ratio between diameters or radius, in case you have radius, with respect to the speed. So again, what we have, the biggest pulley speed divided by 60. And that will generate for you the answer omega, or the speed for the driven pulley, which will be 174.5 and radians per second. Now, this is a very, very interesting topic. And I think for some reason, I don't have the answers for your test, or I may have it here around. Let me check if I do. Because I want to just look into the question you guys got in the test. No, I don't have it, and I can't find them online as well. But don't worry. So technically, this is how can you start working on this kind of applications. Oopsie. Do I have the test for this one? No, I couldn't find the test for your the questions for your test, but don't worry. Okay, who's saying? Michael is saying, I'm not getting the part. Okay, so to find the speed in for the smaller pulley, it's the ratio between the biggest speed and the speed of the bigger pulley with respect to the small pulley, and that will be an equation. If you go to the lecture notes, I'll write it for you, the equation, which will describe that for you in 1 second. So, okay. So to find the speed, I'll write this equation here. So what do you have? You have insert equation as a ratio. You have n speed divided. So which speed is this? This represents the speed of the bigger pulley. So it will be 1200, right? RPM. Divided by what's n, which we don't know, the speed for it. This is in case I'm getting it by revolution per minute, okay? Equals to what? And again, equals to the diameter for the 250 millimeters divided by the diameter of the 180 millimeters. This is a ratio. If you multiply using the cross methods, you will get the answer. Okay, if we have 2 RPM in the question, 1,200 revolution per minute and 600 revolution, which one? Add this equation? Ranjit, you should, it's different. In this question, each pulley should has a speed. So you cannot use both speeds at the same time. In the same equation, you may find the diameter for the smaller pulley. Sagal, is there an equation for the power in angular motion? I think there is. I'm quite sure there is. Let me check the formula sheet for this one. Power, it's equal force times distance, and force, sorry, the work is equal force times distance, and power is equal work divided by time. I'm looking for the formula sheet here. Friction. I did using the net force times linear velocity. Yes, you can do that. Of course, you can do that. But there is another easy way to do it. It's just the net force times times the distance. That will be torque. And if you multiply that torque with the speed, and then you go through it. So there are 2 different ways to solve this question, and this is one of them. And this is kind of a shortcut for that application as well. So don't confuse yourself about this kind of questions. I hopefully answered Michael as well question, because that's about the ratio. You say, I don't know how to solve part C. So this is the equation we need for part C, but the only things, he wants the answer in radius per second. Yeah, perfect. All right, so just very simple questions. You can do it in that way or in different ways. And the problem I'm trying to see, where can I find your test 2 paper? Because I think test 2 was on Moodle, but I can't find it anymore. But anyway, something similar to that. I'm just trying to see if I can find it, but not really. But don't worry, should be fine. Yeah, no, it's all good. So if you guys are a bit confused about this topic, I really guys recommend you go to the lecture notes under Moodle. So when you go to Moodle, you go to the topic linear angular motion, click on the required reading linear and angular motion. You find the last example. It's very good and helpful to find omega and what's the difference between capital N, which is speed, and RPM, and omega radius per second. So it's very, very good for you guys to find that, and especially when you try to solve these questions. All right, let's see what's else now. We have, it's in resource, I think. Yeah, I think it's in resource, but I couldn't find it for some reason. Anyway, I'll go with my way, seems simple. Yeah, go with your way, seems simple. If you feel your way, it's really easy for you, definitely stick with it. But again, the reason I work it out for you, because remember, in the question, they ask you first to find the torque. So you need to find the torque. And then when I find the torque, I just multiply it by 2 pi n divided by 60, I got the power. So sometimes the direction of the questions will lead you to certain solutions. If your way requires to do extra jobs, it's fine and you're confident with it. So that's nothing it's bad about it. All right. Now, since you guys finished this example, then let's try something different. Example 5. As I promised, today I want to do as much as I can from examples. I'll give you time to read this example. A pile-driven hammer of mass 5 kgs falls 5 meters from rest onto a pile of mass of 150 kgs, assuming there is no rebound. Calculate the velocity of the hammer just before impact with the pile, the velocity of the hammer and pile just after impact with the pile. How much energy is lost in the collision? It's a very good example. I want you guys to try it step by step, and then we will have a discussion about it. If you manage to get me the answer for first part, which is the velocity, will be awesome. And then we can do part B and part C. This topic is related to energy. So my recommendation for you to think about energy in and energy loss in the system. And then you can find, we have two different types of energy. It could be potential, kinetic in this example. Potential because of the elevation. Oh, okay, you say that way, torque is times angular velocity. Yeah, that's easier one. Yeah, torque times angular velocity will give you the power. And the reason we went in that direction, because we just found the torque. So as soon as you multiply by the angular velocity, that's what give you the value. And now it's your choice to go on that way or you go the other way. So I want you guys to try part A. If you can submit on the chat, what's the answer for part A? Did we get the answer? Matthew, perfect, well done. Did anyone join us recently? Because I see a number increased. Yes, yes, Michael, you use that. Yeah, what did you write to me is all right. Caleb, correct. Answer is correct. Parpinder, no. Try to recheck your answers. Sagar, your answer is correct. So for the guys who got answer A correct, continue. Ronil, what's the question? You haven't figured out? Let's do it together. All right. So to answer this type of questions, it's very easy. So let's do it step by step. So a pile-driven hammer of mass 500 kgs falls 5 meters from rest onto a pile of mass 150 kgs, assuming there is no rebound. And calculate the velocity of the hammer just before impact. No, Michael, Chandra, the answer, what you got is not correct. All right, so how can we start with this kind of questions? Let's do it together. Insert. Do it here. So To start this kind of questions, you need to have, it's related to conservation of energy. And what you have in this example, two different types of energies. So the first one is, what I'm doing. So you have E potential equals to E kinetic. And then we'll try to define what's the difference between potential and kinetic. So if we try to write the equations, so potential for the first one, this one, it's falling down. So what do we have? MGH, I'll write the equation so you guys can know, is equals to what? 0.5, which is half the mass times what's V squared, the velocity square, V squared. So very basic, mass times gravity acceleration times elevation h represent the potential energy. Half or 0.5 m mass times V squared represent kinetic energy. All right. If you look carefully, here what we need to determine. M is constant. We're talking about the same thing for the hammer. So the hammer has the same mass. Therefore, M will be cancelled from both sides. So what's remaining from that equation? G, which is 9.81, times H is 5, times 2. Now you say, where did you get the 2 from? Okay, very easy. Because when I convert this 0.5, move it to that side, remember it was 1/2. If we could write it in this way, I can move it to the other side of the equation, will be multiplied by 2. All of that is equals to what? V squared. This is when in taking into account that M is constant. So I'm just using the information here to show you how it works. All right. Now, taking the root square for V square V, that will give you an answer velocity. It's equals to, as many of you guys submitted the answer, 9.9 meters per second. That's the first part of this question. So that's part, if we call part A. All right? Very easy. Nothing is complicated about it. So try to think about it. So, I mean, 75, not 13. No, I don't think you're right. Sagar trying to answer part B. Sagar, part B, it's slightly different from what I have. So I will ask you to recheck it again, Sagar. We can do it together. We can do. Matthew, yes, your answer for part B is correct. Caleb, yes, correct. Buddy, no, for part B, you're getting a wrong number. Because here's the trick, which we'll discuss very soon. All right, let's do part B. So for part B, what do we have? Try to find the velocity of the hammer and pile. So it's mean the velocity of the hammer and the pile together. So let's highlight this just after impact with the pile. So technically, you have a difference equation you need to use. So it's M1V1, and I want you guys to rename this equation, especially Matthew. M1 V1 plus M2 V2 equals to the summation of M1 plus M2, all of that multiplied by the velocity of so we call it, let's call it V3. So what does mean this equation, guys? Any idea? What's this equation I did right? What represents? So the velocity of the hammer and pile just after impact with the pile. So that's V3 represent for us. Now, M1 represents the, good, Matthew. This is the total momentum. So what's the total momentum we have? M1 V1 represent the mass for the hammer, which is 500 kgs, times the velocity of the hammer we just found, 9.9 meters per second, plus what do you have? The pile, which at the beginning there is no velocity, but there is a mass. So technically, if I try to solve this equation, I will show you how it works. So M1 is 500, the mass of the hammer, multiply the velocity we just found earlier, 9.9 meters per second, plus, now I put brackets to just not confuse you, what's the pile mass is 150, it's giving in the question, times, what's the velocity of the pile? The pile is at constant, is not moving. So technically that will be 0, equals, or close the brackets, equals, now the total mass after impact, what should be that one? So you have 500 kgs plus 150 kgs, so the mass of the hammer plus the mass of the pile, all of that will be multiplied by the new velocity which we found after impact, which we call it V3. Now that part here, it will be end up to 0, because 150 times 0, anything multiplied by 0 is equals to 0. Therefore, we found after rearranging this equation is equals to what? The right number is 7.62 meters per second. And that's the right answer for this velocity. Okay, just a question. When do you use kinetic energy plus potential energy before impact is equal kinetic energy plus potential energy after impact? Just a question. When do you use that? It depends on the question, but at this moment, we don't have potential energies in this question because it's already impact has happened. So the potential energy, we already took it into account and we found the velocity too. Now we're trying to find the total momentum of M1V1 plus M2V2 is equal to what's happened after that impact, both together. And that's a solution for it. Now, the last part of this question, which could be answered many things for you guys. How much energy is lost in the collision? This is a very important question. So I will give you time and to write the equation for that. Darren, your answer is correct. Maybe there is something in it. We check together. It's 5.6, but it's not 7.6. It's something less than that I have, but possibly I'm wrong. So here to answer Michael as well, Michael Chandra's question, how can I determine that energy lost? How much energy is lost in the collision? So what equation will help me to do that? Yeah, 5631 Caleb, yes, correct. Or 31 point something possibly. All right, let's try to solve for part C. So for the part C, what do you have, guys? It's asking you how much energy is lost in the collision. So what do you have? We need to write the equation of energy. We're talking about the collision, by the way. Don't confuse yourself. Read the question carefully and answer exactly. You have energy of kinetics, we call it N, minus energy kinetic out. And we go and talk about them step by step, okay? Equals to what? That will give me the energy loss. How much energy we lost in the system. So E loss. Okay, let's break down one step by step. What's the in, what's the out? So the in is the hammer, the kinetic energy for the hammer. So that will be 1 divided by 2, which is half. The mass is 500 kgs times, if we need to enter the velocity, which we found earlier, is 9.9 square, 9.9 square. That's represent energy, kinetic energy into the system, minus what's the energy we lost? The energy we lost was the energy of just after the impact with the pile. So again, that will be half, so 1/2. Now, what's the total mass we say? It's 500 plus the 150, because it's the mass of the hammer plus the mass of the pile, multiplied by what? We will multiply that by the velocity for the impact, which is V3, which is 7.62 to the power square, equals, if you solve that, it should give you E loss 563, but I really don't like 563. It looks like, so it's about 563, 1 divided by 1000. You could easily write 5.6, for example, kilojoules. I like to submit small answers and not really complicate my life with a number like that. Just change the K to be properly acceptable. So again, to revise this question, yes, that's perfect, Sagar. Now you're on the right direction. So 5.6 is the right answer. And technically, what do you have if we revise? The kinetic energy into the system, which is coming from the hammer. It has a 500 kgs. Velocity we found 9.9 meters per second. And then there is energy lost after the illusion, or collision, sorry, which is mean the total mass of the hammer plus the pile, which is 500 plus 150 kgs, times the velocity we found, which is the velocity 3, it's after impact, 7.62 square. You arrange this equation, or not, just solving it straightforward, you find the energy loss in the system is 5.6 kilojoules. Very easy and very straightforward application. I hope you guys you find it easy, like not really that complicated. If you have any questions before we move to this other question, just feel free to ask. Any questions? Cool. Ibrahim is here. Please, who start joining us in the last second, can you write me something on the chat so at least I record? Because I'm taking the attendance as usual. And if you're watching this with your friend, just let me know. Michael, potential energy when you have elevation. After the impact, the hammer and the piles are attached to each other, so there is no elevation anymore. And the first elevation, we already did calculate that in MGH, which is that's happened before the impact. So the question is divided kind of in two parts. One is before the impact. The second part is after the impact. After the impact, is the hammer is attached to the pile. And that's what we want to find, how much energy lost from that. And don't worry, I will solve another question about energy, since it's a bit confusing you. All right, since no questions. All right, let's try this another example. Fluid principles. Definitely, guys, you will have a question in your exam about fluid, and that's something very normal. This is example number 5. We hopefully, if we're going in this way, we can do much examples. So, find the force on the stop block. The gate is pivoted about a horizontal axis passing through its centroid. When they give you this information, really, when you read this kind of questions, highlight the information given to you. First of all, seawater is given as relative density of 1.025. So the density of the water is 1,025 kgs per meter cubic. Other things is giving to you guys here that this is a radius. So when you get this sign as a phi, it's mean this is a radius. 2 meters phi gate is mean this is a circular gate. And it's a radius, so the centroid of it is half of the 2, it's 1. So radius 1, 1. The total diameter is 2 meters. So sorry, phi represent diameter, not radius. Sorry for that. Now, it's giving to you that from the surface of the seawater till the center of that gate is about 5 meters. So it's kind of he's giving you the H value you're trying to use to find the force. So in this question, he wants you to find the force on the stop block. So this is the stop block, it's highlighted here. So we need to find the center of force and take a moment about the pivot, for example, and then we can determine the stop block. This question, it's required a lot of processing to work with. It's kind of applying the centroid and as well non-concurrent forces, such as taking a moment around the point and other applications. So first of all, I personally did draw the question again to make it really easier and for you guys to read. So technically, I took this drawing here on the side and just redraw the question from scratch to make it more easy for you. Now, and that's how it looks like for you. So this kind of, if you look to the side of that, is showing you how it looks like this gate. So it looks like a circle, diameter of 2 meters. And as well, it's showing you that the distribution of the pressure at the top, it reads 0 gauge pressure. At this point, it should read a very high value of gauge pressure, which is rho g h. H should be 6 meters because from here till the center is 5. This from here is a radius is 1, so 6. And we need these values. The density of seawater is 1,025 kgs per meter cubic. Now, force is equal to what? Rho GH. Now here you remember there are confusions. Do we use half? Do we not use half? What I told you guys, always allocate the distance from the surface of the water to the centroid of the object for it. Since the object we're trying to study, is fully submerged under the water, then different rules will be applied for it. So H will be reading from this point, the surface, to the centroid of that. And if you see, the question is already given to us, 5 meters. So density, 1,025 times gravity acceleration 9.81 times 5, which represent the edge from here to there, times area of the gate is circular. Please don't forget that. This is not a rectangular gate. It's a diameter 2 meters, so pi over 4 2 squared. This is a very, very common mistakes from students. I have seen them. They don't look to information because this is telling you is a circular gate. You can see that shape is represent for you as a circular. So if you, for any reason, you multiply 2 times 1, you will definitely get different area from that. Solving this will give you an answer of 157.947 kilonewtons. That's the amount of the force. Now, what I want you to look, guys, here, this is really very, very important. The distribution of this force, it should be allocated at some point, or the location of this force some point below the centroid of this pivot or centroid of the gate. So technically kind of will be around that point. And if we want to try to find the centroid for that from the surface of the seawater, we need to apply some kind of area using what we done for finding the centroid for different areas. So if you look to that triangular, that's a distribution. But the one we are interested, actually, this one and this one. So we have rectangular and triangular. And this one is not important for us because we're trying to study, as Michael Robinson told us, is similar to the UDL, the uniform distributed load coming against that gate of 2 meters diameter. Then what we do, if we try to find the area, the first area for this triangular, triangular, yes, this one, area 1, it's half of the base. So what's the base? Very easy. How can I find the base? If all of that's till here, h represent for me 4 meters, because 5 minus 1, which is the radius, that's 4. And so that's distance from here is rho gh, which is 4. And that's one rho gh 6, because from here to there is 6 meters. So rho gh, so what you do, you just subtract. I'll write it down here so you guys can see what I'm doing, at least to not confuse you. Insert rho g, we have 4, so that's represent here rho g4, and I will highlight it in different color, so in red. And the other one, the total, rho g6. So from here to there is rho g6. Now, if I want to try to find that one, what would be the equation? Very easy. Rho g6 minus, so I will take this one again, Control V. So it would be rho g6 minus rho g4. And that will give you rho g2. That's how we derive the equation there, rho g2. Copy this again, and this will be 2. So kind of we're trying to find values to solve that distance. So that small tiny distance, it's coming from the total one, the total rho g6 minus rho g4 will be rho g2. Therefore, rho represents the density of seawater, 9.81 times 2. I found that. So half of the base. Now, what's missing here in this equation, if you look carefully, you say, hey, what have you done? Half of the base. What's about the height? Oh, yeah, of course, the height times what? Times 1. So you don't need to write it because it's a radius. So you can still show it, but will not change the answer for you. Now, for this part, the area for rectangular, you have rho g4, the remaining of that, rho g4, 1025 times the gravity acceleration times 4. And then don't forget to add the times 1, because that's distance. Oh, no, it's not times 1. Sorry, I have done it already. No, it's times 2. Sorry. It's times 2. Half the base times the height. So the height is 2, and then you get the answer. Just let me correct if I have got the right answer for this one, because sometimes I solve things, but I don't use them. Times 9.81 times 2. Yeah. Times. Okay. So area 1, half of the base, rho gh2, times the height, which is 2 meters. And area 2, half of, like you get that distance, 1025.181 times 2, which is the entire of that. So that should be about 20.11 divided by 1000. So it's 20.11. See, that's sometimes these kind of questions are very confusing, and you need always to look into them carefully. Now this one, the second one, it's 1025 times 9.81 times 4 times 2. So that will be giving you 80 divided by 1000.44. Now I need to update this one, so that will be 20.11, and this one is 80.442, and this one is 80.442, and this one is. So what's the difference? Because I didn't take into account that's 20.11, and now I'm not taking the 10 to the power 3 because they cancel each other. 80.442, and then we get you the answer. Are you guys with me, or you a bit confused? I know it's a bit funny question, this one, but I'll try to solve it for you guys so at least you know. Now what's the centroid here for this one? So the first one, y1, which is represent for me 2/3 times 2, and then all of that's going to the height. So can you say again how to get the rho G4 and rho G6? So rho G, it's the pressure at this point is rho G4, and the pressure at this one is rho G6. So it depends on the elevation. So from here till there is 5 minus 1. And from here to there, it's 5 meters time plus 1. And that will give you the rho G6 and rho G4. All right, so go back again, and let me try to get the answer for this one. 20.11 times, what do you have? 1.33 plus 4. Please, guys, check with me if something I have missed. 80 plus 0.442 times 5. All of that divided by the summation of 20.11 plus 80.442, and that will give us 5.06. So my answer was correct, but just I did mistake with my calculation. So the answer is 5.066. So I just had a mistakes when I was typing this, because what it's basically what you have half of the base. So the base is rho G2 times the height. The height is the gate, so the entire diameter of the gate, which is 2. And for this shape, so what you have, rho G4, which that's the distance for that, times the height of that, which is 2. And then I got the answers, and simplify it, and then you get the same answer. So what does mean that? That's this force we found earlier, the force of 157.94, it's away from the surface with a distance of 5.066. So I will highlight this number. So that's the distance, how far this force from the surface of the seawater. Why it's important for us to find the force? Because when you're trying to find the moment about a point, you need to find the dimensions for it. So the question is, if I want to find how far it is from the pivot, it's just very easy to do that. You just need to determine that the centroid is 5 minus or 5.066 minus 5 will give you 0.06. So that small tiny distance, I will highlight it for you guys here. I know it's getting too much. This kind of question, they take a lot of space in your paper. That's tiny distance, this one, is 0.066, because where it's coming, 5 meters, or this one, 5.066 minus 5 meters, and you get this small tiny distance. Now, but that's not the end of the solution, because he wants you to find the force to stop, or to stop the block, the force on the block. So how can we do that? I'll show you in more better diagram. So we allocated this force. This is the distance we found earlier. This is the value of the force we found from the solution, from the first part. And this is the force of the block he wants us to determine. So if we apply non-concurrent forces, you take a moment about the pivot. You can take it, let's say, clockwise. So what do you have, or counterclockwise, depends on what you assume. The 157.947 times what? Times that small tiny distance, which is, this should be actually the opposite, should be 0.066 minus, because you put the big number minus the small number, so you don't get negative, equals to what? The F block to that point. So we kind of taking a point of the pivot. So from that to this point is the radius, which is 1 meter. You rearrange the equation and then you find the final answer is 10.424 kilonewtons. To get more clarification about this, I just zoomed in here and I'm showing you how to do it. The distance here, remember, this is a diameter. So that small, tiny distance to bring it here, this small distance from the block to the pivot is about 1 meter. That's why we're solving it in this way. I know it's a very a lot of involvement in this question, but if you work it out step by step, hopefully you don't get confused and will not get you. Now I have a question. Can you explain the Y1 and Y2? Okay, yeah, I can go and explain Y1 and Y2. Where is it? Y1 and Y2. So Y1. So Y1, it's actually the distance of the centroid for the triangular shape. So where is that centroid for it? We know is 2/3 of what's the height. So the height is 2 meters because of the diameter. 2/3 of it's from the top. So that will give you 1.33. That's the 2/3 of the 2. Plus what? Plus the 4 meters to go to the surface, because we're taking our reference point to the surface. Now, the Y2, it's for that. What's the centroid for the rectangular? It's already given to us, which is at this point, 4 plus 1 meter, which is the radius, and that will be 5. That's the Y1 and Y2. We'll have a question about centroid today, so hopefully we cover something like that. If you have any other question, please, about this example, feel free to ask. The only issues I had with it is actually when I did it and solved it on paper, I got the answer correct, but I forgot to add the 2 here, which is, or multiply the 2, because it's the area. So this represents half of the base, all of that components, times the height. And this one, W times H. And this will represent for you. So in other words, this, if I bring this value here, this is rho G4. For that one will be 2 and Control Z, and let's see, Control V, and this one is 4. So I'm writing the values for you guys on the diagram to show you. So half of that should make this one maybe bigger, so at least to make you show some difference, like twice the dimension. Okay, so for the rectangular is rho G4, for this one is rho G2, and that's how I'm showing you. I didn't get why Y2 is 6, I mean 5. Y2, because the centroid for this rectangular, it's from this point to the top. So it's 4 plus 1. From here to here, it's 1 meter because it's the radius of the gate. So I'll write it down is 4 plus 1. And then you solve it and you find the answer. So this one is showing you the dimension. Both of them, they should have, let's make it more logical, like they should have the same height, like 2 meters or 2, which is this value. This represent 2, and this should represent 2. And then you solve this question. I will give you this. I mean, the answer solutions and the answer guide, they're really messy. You may not get it exactly the same way how they solve it, but this is actually the step-by-step how to do it. So if you follow that. Now, one thing I want to discuss about this topic, because sometimes it's a bit confusing, you guys, and I want to really clarify these things. Especially you may get some confusions, and I want you to avoid any confusions about this. One of the most important things about this kind of applications, it's let's say okay, so let's say I have this gate. So, and I want to test you with it as well. So this is surface, and just let's do one and insert, and let's put a gate something like this, and then we change that to show you some techniques how to fill the formatting. Let's say that we have a gate like this, and then we bring a fluid, which let's say, okay, let's do this scenario. We do it scenario by scenario. I like my leveling of the fluid. Control C, Control V. Okay, so this is the gate, and this is a fluid in it. So I want to discuss with you guys, how can you calculate the force in this kind of applications? So do you remember the force is equal to what? And then we write the equation. Force, write the equation, insert F is equal rho GH, rho GH. And remember, we say half, but that half confuse you guys a lot. Multiply by the area of whatever is the object we're trying to study. So I want to discuss this in more detail, so at least we avoid any confusion about this topic. So let's say the fluid is water, so we'll give more information here. Is equals 1000 kgs. I'll get the units from the last example just to save my time. So this is the fluid, and let's do scenarios, different scenarios. Let's say, one second, I'll put all the scenarios. Okay, now, let's say this is the gate. This is the value of 5 meters depth. Can we find the answer for it? Now, what you need to know, we can put the units, 5 meters, and we can do the gates. It's the width of it, let's say, whatever is the value for it. So take it as 1 meter. W is equal 1 meter. Okay. So if I try to find the force on this gate, how can I do that? Remember always what we say. If it's really start from the surface, then I'll start using the equation. Rho is 1000 times what? 9.81, the gravity acceleration, times what? Times h. In this case, h, what do you think should be? Because it's starting from the top, from the surface, so it's covering the entire gate, so I will write 5 divided by 2, half h, which is 2.5. Now, what's missing in this example? So times, so I'll put brackets to not confuse you, times is the area of the gate. So what's the area of the gate? The area of the gate is represent for me the height, which is 5, times the width, which is 1 meter. Okay? And then you find the answer in, for example, newtons or kilonewtons. This is scenario 1. This is when the gate is just on the surface. Now let's change the scenario slightly different. This is, we call it 1. What about if we change it to bring this information? Okay. Let's bring this down here. Okay, so it's the same gate, and now you have a new value of this. Let's call it 4 meters. Can you write me what should be the equation of the force? So I haven't changed anything. I just dropped the level of the water. Let's say we have a tank and we start losing water. First it can fill to 5 meters. Now it's 4 meters. So what should be F for scenario 2? F equals to what? Rho GH times the area. Did the area change? Yes, it did. And that's why I want to ask you. So I'll give you time to write the equation. I don't want the final answer. I just want the equation. So Matthew, yes, correct. But what's missing? Two. What's the area, Matthew? You forgot the area. No, correct. Yes, Matthew, you're correct. Your answer is correct. Michael Chandra, is the 3 the area? I can't see any 3. Can't see the area. 3. So to help you in this question, so what will be here. No, area, you don't add area 2 plus 1. Rho GH 2 times 4. Perfect. So what will be? Density is 1000. Nothing's changed. Multiplied by what? 9.81 is the gravity acceleration. Now, what's the value of h? So h is half. So it will be 4 divided by 2. Now, the area is what? The area is 4 multiplied by 1, because I will only interested in how much the water is covering. That's where it's very important to find out. See, that is the difference between the two different applications. When you have the area is going downwards, so you start always to take into consideration, I will highlight it. So the area I'm trying to study is this one. This is where I'm interested in, that location. So I will just make sure it's this and change this to red. So that's this is exactly what I'm interested to do. Since the level of the water is dropped, so technically there is no much pressure on top of the surface of the water. There is nothing. So you should not really take the entire area of the gate. You only take whatever is under the water. Now, what's the difference between this one and the previous example I show you? The gate is completely under the water. Therefore, you treat it slightly different. So we have the H value, which is giving it's completely different scenario. This is very, very important. When we have a fully submerged gates, you take the entire distance for it, but to the surface. So from the centroid of the gate, center, to the surface. When it's already the gates at the surface, like scenario 1, the 5 meters, half of the 5. When we go to scenario 2, 4 meters is dropped, we take 4. But the other tricky things, see, we took that area. We took 4 times 1. We didn't take 5 times 1, because now we just concerned about that. Can I read it again? It still doesn't ring a bell. Yes, Michael, you watch this video as it's recorded. All right. So this is very, very important for you guys in the applications you will have in principal fluids. Okay, that sounds good. Better. All right. So that's what I wanted to do it. Now, if I change this and I say, hey, instead of that shape, I could have a different shape of an area. So let's say even if that shape, it's Control Z. Let's say the shape of that, if I want to project something, so 5.56. 5.56. And then we patterns, we use this one. So if in case they say, hey guys, This gate is actually, if you look into it on the other side, it has a circular. So what does mean that? And we go back to this scenario when it's fully submerged. Let's say the gate for some reason was a circular shape, then definitely you will use the area will be changed. So now we have a new scenario. What's the new scenario? We write it down. 3 F is equals what? 1000 is the density times 9.81 times, what's the center for that? Again, it's 5 divided by 2 because from the surface of the water times, now the area is completely changed. It's not anymore you multiply two products. It's pi over 4 because it's circular shape. So pi is the value divided by 4 times the diameter square. So let's say the diameter in this case is 5 meters, and that will be squared, and then you get it, the area. See, it's the same question, but I am showing you three different scenarios. How can we use two different values in it, such as changing the area or changing the elevation of distance? And this one should comes up. So at least makes sense to the question. All right. So this is a very thanks. So this is kind of, we call it side view. So to not confuse you, let's put something like that. Side view. And it's kind of like it's a pipe. Technically, this only happens if it's a pipe. So if it's a pipe, and of course, it could be this gate is designed to be a circular shape, and it's mean this side's coming from that direction is also a pipe, and it's covered because you need to seal this pipe from all the directions. So technically, that's the only way it works. All right, so a pi over 4 d square or pi r square. It depends on what you use, if you use radius or diameter. Okay, so this is something really, really important for that. Now, the last example I want to discuss today is the question many of you did send me about this one, and then I'll go through a couple of questions. All right, this question, I think it was a past exam question from, I don't remember, 2015. So a woman starts a motorcycle from the top of the hill, point A, and the mass of the woman and the motor bike is 350 kgs. Starting from rest, she rides 150 meters down the hill, which has an incline of 25 degrees at a constant thrust of 2.5 newtons per meters. She then rides along a 100 meters level section of road at the same constant thrust. So the thrust from A to B is constant. The only difference between A and B, A has potential energy because it's higher level. Then she rides 60 meters up to the top of the next hill, point C. So then she's going up, which has an incline of 30 degrees with a constant thrust of 3 newtons per meters. The frictional resistance for the motorbike and the rider along the road is 1 newtons per meter, so every meter is 1 newton. Using the principle of energy conservation, determine A, the velocity of the motorbike at the bottom of the second hill, point B. So we're trying to find from A to B. And then the velocity of the motorbike when it reaches to the top of the second hill, the velocity at point C. And the last one is the work done by the motorbike to get from point A to C. How much work is it's to get? I'll go through this very easy because I will share this with you. So if we use the energy equation or energy conservation equation, principle of energy conservation, between A and B. Why A and B? Because we have the 2.5 newtons per meter is a constant thrust. So it's kind of things are constant in it. So what do you have? Potential energy at A plus energy added between A and B, which could be found by area, equals to what? At B, you have technically you have the kinetic energy, and you have energy lost due to the friction. So if we try to solve the first one, and since she's starting from that point, so the velocity there is no kinetic energy, velocity is equal to 0. So potential energy is 350 is the total mass, the lady and the motorbike, times gravity acceleration, times the elevation. We just need to use the trigonometries. So 150 sine 25 degrees plus. Now, how can I find the energy added due to the thrust force? So what's given to me is saying every meter there is 2.5 newtons. So she's done 150 meters plus 100 meters. So that will be 250 meters in total times the 2.5. That will give you 625 thrust force during her 250 meters, the displacement. If you look to this shape, is technically a triangular. So half of the base, half of the 250, times the height, which is 2.5 times 250, which is 625, equals, what do you have at point B? You have kinetic energy, which we want to find the velocity at point B, and the mass is the same, plus you have a friction or energy loss between A and B due to friction. So what's telling us in the question, if you read carefully, there is a friction of 1 newtons per meter. So she's done about 250 meters distance times the friction 1, which will be giving you 250. So you kind of creating another triangular. To find the area of that is half of the base, 250, divided by 2, times the height, 250. And then you solve it, you get the velocity at point B is equal to 38.89. This is a question many of you were confused about it, I think. And now I'm doing it, showing you step by step. Now, the other part of this question is to find the energy, or sorry, the velocity at point C. So what you can do, should be updated. Oh, sorry. Yeah. So we're trying to solve it by finding the velocity between B and C. So between that point and that point. So how can we do that? Very easy. What you have at B, if you look carefully, you don't have a potential energy. You only have a kinetic energy, which we already found the velocity. But at C, you have potential energy and energy lost and due to friction. But at B, we have a thrust. So let's try to work it out. So you may end up a diagram like this. You have a thrust force, which is showing you what's happened between the 250 and then another 60 meters of displacement increased to reach the 310. So this is between B and C in thrust force is increased about 180 newtons from 625 to 805. On the other side, we have a friction loss, which is an energy loss from it, and those 60 meters. So technically, when she's going up that 60 meters, she's losing energy. How she's losing it? So again, we found that value by this 60 times 1, we could represent for you the friction is 1 per newton, newtons per meter. And then you look to those diagrams. We got a new areas. One is rectangular plus triangular, rectangular plus triangular. So we write the equation. Kinetic energy at B plus area of energy added from that due to the thrust. So what do you have the area? If we look carefully here, the first one is 625 times 60. It's missing here 60. And plus half of the base, which is 60 times the height, 180. All right, now equals to what? At C, we have first kinetic energy. We're trying to find the velocity at C. And we do have potential energy, 350 mgh. So what was that distance? It's here is missing to say 60 sine 30 degrees. So mass, and that's multiplied by that. You get the values for it. Now here is a loss in energy. We got it due to what? To friction from B to C. So the first one is a rectangular. 60 times 250, that's represent the first area. And then we got, that's half of the base, 0.5 times 60 times 60. So kind of half of the base times the height. You rearrange, you get the answer 32.8 meters per second. The answers, by the way, for this solution is available on the Moodle, but I think it's not really showing you step by step in detail for that. Who's writing on my PowerPoint slides, guys? Please, can you stop? All right. This is a question I wanted to go through it because I'll publish these slides, plus you have the video so you can go through it. Now, there is something very, very important to calculate the parts, the third parts, the work done by the motorbike. It's all by areas, and we have done it step by step, but you only wants to calculate that. So what do we have? First of all, this area, half of the base times the height, plus this rectangular, plus this triangular, half of the base times the height. Now, if you look carefully to this shape, it's really very interesting because from A to B, we had 2.5 thrust force. But from B to C, the thrust force became 3. And that's why the triangulars, they are not really. So the slope is going here as a slope, but then it's going to different direction from B to C. Therefore, we split it up to different. So here's 3 newtons per meters, and here's 2.5 newtons per meters. So that explains to you why we can't find the area under the big triangular, because they are not really uniform and they don't have the same dimensions. All right. Of course, I promised you something about a draw shear force and bending moment diagrams. I would like to share with you something very, very good and powerful. It's just something you can practice when you're trying to work on it. And so I will share with you the solutions later, but as well, I want you to go to this website. If you use it for basic use, it's very free. So what's the purpose of this website? This website is just calculates for you free body diagram for the application and shear force and bending moment diagrams. So Sky CV, this company, and it's very easy and beam setup. So let's say this is the beam, how it was set up. You have a cantilever, a UDL, and one at the end of one of the ends, or at 1 meter from the free end, 5 kilonewtons. Very easy. You set up this software and then you can solve it. So I will set up something for you guys. Yes, restart, very easy. You can see this web if you just Google this one, HTTPS Sky CV. So you add a beam. Let's say the beam is 2 meters. And then with sketch for your beam, add support reactions. So let's say one end at 0, it's pin supported. At the other one, we can have roller supports, so say 3, or you could do it at 2 meters. Let's do something like that. Let's do it at 1. So kind of we have one end is free. So the entire length of the beam is 2 meters and one of them. Now we can add distributed load. So start location, let's say 0.5, and end location is 1.5. And we have about the value of 2. Because it's constant, so we add it as a constant. So that's a UDL represent for us. Add point load. So you can add this point load. Let's say this was going downwards, location about 1 meter will be in middle of the UDL. Let's put 3 kilonewtons. Add. By the way, if you want to change units here, you can come in newtons, or you can use British distance in meters or millimeters or inches. So kind of. Now, some people, they may add point loads going upwards. Distance of 2 at the other ends, 2 kilonewtons. Very easy, this software. So why I'm teaching you this, guys, because this software is saving you from this. You can design anything in this software application, and then you can compare. I recommend for you guys to solve it by your own, and then as soon as you click solve, this software will find you the support reaction forces, and then you can compare your results. So it's converting for you. So it's found that the support reaction at that point is 2 kilonewtons, at that point is 1 kilonewton. And then this is the shear force diagram, how it looks like. And this is the bending moment diagram for that application. It's very helpful. It's showing you how to do it. Now, one thing it doesn't show you, it's how to calculate step by step, but you should really do these things by your own, because since you are at that level. So you can use it, you can generate cantilever. So if I go to the PowerPoint, because I think the session is finishing very soon, I just want to sum it up, to make sure. So if we come back to this, it's another example. It's showing you step by step how to calculate support reactions, and then you draw free body diagrams for draw the shear force and bending moment diagrams, and showing you where to find the maximum. I have another example for cantilever, and draw the shear force and bending moment diagrams, and how you convert the cantilever to moment and support reaction. You find the values, shear force diagram, and then bending moment diagram. Always try to solve them by yourself, and then you can compare the results. One hint for you guys for the exam: when you get this type of questions, such as find or draw the free body diagram. So if you have this shape for stress analysis, you always draw the stress analysis and put the external loads on it, and then convert the support reactions to forces, and you will get about 2 marks for this kind of question, as you've seen from, I think, this 2017 past exam paper. So this is a free body diagram. I put everything from the original diagram, and I put here AX and AY, and then at the roller, only one support is E, and here is this watch actually should move to this point, the 1 kilonewtons, and then you do it in that way, and you show this. The solution is available, by the way. You can work it step by step using, to find the support reactions, you need to use non-concurrent forces, and to find joints or the truss in each member using concurrent forces. You can also do free and right. Yes, you can do. In that software, you can do a lot of different applications. It's just showing you how to do it. Last thing, I also have prepared for you questions about centroid. This is also a past exam question. As just remember, when they give you information in the formula sheet, is a good recommendation for you guys that sometimes you have this cone. You may say, hey, I don't really know how to find the centroid of the cone. Please, the centroid for the cone is h divided by 4. So don't panic. Go to the formula sheet. You find some information will help you to find, for example, the centroid for the cone. I have done the solutions for you guys step by step, and showing you how it looks like the shapes, and rearrange them and recalculate, and then you can go through it. I think by this we have been almost 2 hours, so I will stop the recording.